In this video, we're going to look at Module 4, Note J, Linear Applications. Keep in mind that in the previous set of notes, we looked at slope and how to write linear equations. You're going to see that these problems really follow right from that. They are just contextualized into the different scenarios described in the problems. Now, when we solve linear model problems, linear application problems, this is a good guide of the steps to follow in general. First, we want to think about what are the variables in the problems and what do these variables represent? What points are given? Is the slope given? And if it's not, can we find it? And then we're going to plug into y equals mx plus b. You can also choose to use that point slope form as well if you prefer that. I'm going to stick with y equals mx plus b. And then we need to make sure at the very end that if the problem requires us to, in the context, that we replace the y with whatever the function name is. So for example, in a lot of cost functions, we might need to replace it with c of x. So just be aware of that function notation. Now, as I work through these problems, realize that the numbering in the problems I'm doing in the video correspond to the numbering that's in the homework. So number 1 here will mirror number 1 in your homework. So in number 1, we have a prepaid cell phone company that charges $18.75 as a monthly access fee and 10 cents per minute of calling time. We want to express the monthly cost C as a function of X, the number of minutes used. And then the second part asks us, what will the monthly cost be if we make 397 minutes of calls this month? So what we need to think about in this problem is that no matter what, you have to pay that monthly access charge of $18.75. And then your cost is going to increase from there of 10 cents for every minute of calling time. Now, it also lets us know here that our function notation is going to be c of x. So we've got to make sure that we use c of x instead of y. Okay. So in thinking about our variables, let's make c our cost. And we're going to make x the number of minutes used. Okay, and that's given to us right here in the problem. It says express the monthly cost C as a function of x, the number of minutes used. So since C is a function of x, we're going to be looking at C of x equals mx plus b. So I'm using that generic y equals mx plus b, but I've gone ahead and replaced that y with c of x because we have that notation. Now, if I use no minutes, so 0 minutes, I'm still going to have a cost of $18.75. So that means this $18.75 here can be represented as the point 0, $18.75. Now, think about what's special about this point. This point is your y-intercept. So because it's your y-intercept, it actually is telling me that my b value is $18.75. So I've got my y-intercept, I have my b value. I still need my slope though. Okay, now it tells me that for each minute used, the cost increases by 10 cents. This represents my slope. So this 10 cents per minute represents my slope. So this is my m value, my slope. Now let's just put the pieces together. So we have that c of x equals 10 cents per minute, so 0.10x plus $18.75, 18.75. This right here is my cost equation. Now, this question goes on to ask me what the monthly cost would be if I use 397 minutes. So what I need to do is I need to plug in 397. So I'm going to have C of 397 equals 0.10 times 397 plus $18.75. Now, a calculator can certainly come in handy in these types of problems. You're going to find that this is equal to $58.45. All right, now this next problem is another cost function. It says Jane has a prepaid cell phone plan with Splint. She can't remember the exact cost, but her plan has a monthly fee and a charge for each minute of calling time. In June, she used 210 minutes and the cost was $143. In July, she used 720 minutes and the cost was $398. And we want to express the monthly cost C as a function of X, the number of minutes of calling time she used. All right, now when we look at the information that they've given me, we are still using C as my cost and X as the number of minutes, just like we did in number 1. But they give us some other information that we're going to be able to use as points in this problem. Okay, so if we look at this, it says in June she used 210 minutes and the cost was $143. That is going to be able to be written as a point 210, 143. And then in July she used 720 minutes and the cost was $398. So again, we can write that as a point 720, 398. All right, so if I have 2 points, those 2 points will allow me to find my slope. Remember that when we're looking for slope, we're looking for change in y over change in x. So y2 minus y1 over x2 minus x1. So let's first calculate our slope. So we've got 398 minus 143 over 720 minus 210. Now, again, calculator can come in handy here. When we simplify this, we should get a result of 0.5. So 1/2, we're looking at a slope here of 0.5. Now, we still need to find our B value. So at this point, sorry, I erased earlier an accident. We've got our 2 points. We also now have that our slope is 0.5. We still need to find our B value. Now, I personally, at this point, like to use that y equals mx plus b form. So I'm looking at C of x equals 0.5x plus b. I went ahead and plugged in that slope of 0.5, but what's happening here is I don't know my y-intercept. I need to find my b value. Remember that I can do that by plugging in an x value and a y value from one of my points. Doesn't matter which point we use, we just got to pick one and go with it. I'm going to pick the point 210, 143. The numbers are a little bit lower. So when I plug this in, I'm going to have 143 equals 0.5 times 210 plus b. And now from here, I need to solve for b. So 0.5 times 210, half of 210 is going to give me 105. Let me squiggle on over here to finish up. So we're going to have 143 equals 105 plus b. We need to subtract that 105 to isolate that b, get that b by itself, and we find out that b has a value of 38. Now, keep in mind, we haven't finished answering this question yet. We still have to write our cost function, but we now have our m value, our slope, and we have our b value, our y-intercept. So we can put all the pieces together now and write our final equation. So what we end up with for our equation is that c of x equals 0.5x plus 38. That right there is the answer to part A. Okay, now part B says that if Jane used 868 minutes of calling time in August, how much was her bill? So we need to plug in that 868. We are looking for C of 868. So we need to do 0.5 times 868 plus 38. And we are going to find that that gives us $472. All right, moving on to problem 3. Problem C says that the population of a small town in Central Florida has shown a linear decline in the years 1991 to 2002. In 1991, the population was 22,100 people, and in 2002, it was 17,700 people. We first want to write a linear equation expressing the population of the town P as a function of T, the number of years since 1991. And then we want to figure out if the town still experienced a linear decline, what will the population be in 2007? Okay, so a couple important things to note here. We are going to be looking for P of T. So P of T is what we're using in place of Y. That also means, though, that our variable is not going to be X, it's going to be T. Okay, so right here in that first part A, it actually tells us that we're going to let P equal our population, and we're going to let T equal our number of years since 1991. Okay. Now, in the upper part, it gives us some other information. It says, in 1991, the population was 22,100 people. That's going to give us information to make a point. Same thing with in 2002, it was 17,700 people. Don't overthink this. In 1991, how many years had passed since 1991? 0, right? In 1991, no years have passed since 1991. So this first point we have is actually going to be 0, 22,100. Okay. Now, in 2002, how many years have passed since 1991? 11 years. So this next point is going to be 11, 17,700. Now, we've got 2 points, and what's actually nice is that that first point is our y-intercept, and so my b value is that 22,100. So we know our b value. We don't know our slope, though, but we can figure it out because we have 2 points. So here we go. We've got to figure out our slope. We're going to do 17,700 minus 22,100 over 11 minus 0. And we are going to find that that gives me negative 400. Now, remember, this is a linear decline, so it makes sense that our slope is negative 400. All right, we've got our slope, negative 400. We have our B value, 22,100. Let's write our equation. We get P of t equals negative 400t plus 22,100. Voila. All right, now in part B, we're looking at what the population will be in 2007. So we've got to ask ourselves, okay, in 2007, how many years have passed since 1991? So in 2007, 16 years have passed since 1991. So we are looking for P of 16. Let's make a little note here. So 2007 minus 1991 tells me that 16 years had passed. So we are looking for P of 16, which will be negative 400 times 16 plus 22,100. And we find out that in 2007, the population is predicted based on this model to be 15,700. Now, keep in mind, in all of these scenarios, check in with yourself to see if your answer makes sense. This particular town was experiencing a decline, so it makes sense that this number is even lower.